In this recording, I want to introduce biomechanics and how biomechanics can influence skill performance. So biomechanics is the study of how the laws of physics and mechanics apply to human performance. It is the study of motion of living organisms. So the general idea behind biomechanics is that a coach or an athlete can improve performance by changing technique or other external factors like equipment. The first consideration must be, what is the required outcome of the sport or activity? And even more specifically, what is the intent of the action? So it may be maximum force, or accuracy, or speed, or perhaps even a combination of those. Once that's determined, then the coach may consider, well, which laws of biomechanics will apply and which can be manipulated to achieve the desired outcome, whether that be force or accuracy or speed or a combination of those. So if the intention of the action is for a body or an object to be propelled as far as possible, then force production is the focus of the coaching, as well as the reduction of any resisting forces like gravity or friction or air or water resistance. So in this example here of batting in baseball, the intent would be to hit the ball as far as possible, apart from batting as the various techniques like bunting, but to hit the ball as far as possible, then force production is a major focus for the coach. If the intention of the action is for an object or a body to move with precision, then accuracy is the object. Therefore, principles such as projectile motion, spin, and reduction of the resisting forces apply, as well as balance and stability. So in this example, in figure skating, precision of movement is important, and so the considerations are to reduce the external forces and to maintain balance and stability. In the example of vaulting in gymnastics, the intent of this action is to land safely, having performed a particular movement of the vaulting box. And so in order to perform that movement such that the athlete doesn't land on their head or in an inappropriate way, then they need to first of all maintain speed in the run-up, so they're generating momentum. They then need to maintain or put the body into a specific position, which is, I guess, part of the accuracy part of the movement, in order for them to rotate their body far enough so that they land on their feet and not on their backside or indeed on their head. So it is the intent in this action is for speed and accuracy and force production. The force production part of it is to maintain enough height in order for rotation to be achieved before landing. In the example of high jump technique, you can see the progression over the years of the technique, and you can see how it's changed to a more efficient technique. So from the scissors to a straddle to the Fosbury flop technique. And so the principles of biomechanics would be applied to show that the current technique is the more efficient technique. So the intent of the high jump is for maximum force at takeoff such that enough height is achieved, but also accuracy of movement so that the body is in a position where it's not going to knock over the bar at the top of the jump. So the laws of biomechanics which can be applied in sport include the study of motion, Newton's laws of motion, speed and velocity, force and momentum, leverage, centre of mass, balance and stability, equilibrium, and technology. Technology applies to the equipment or the clothing or the footwear that an athlete must use in order to perform an action. And of course, with improvements in technology, these pieces of equipment can assist in the performance of that action. So with a couple more examples, we can look at the principles of biomechanics and how they may apply. So in javelin, the intention is to throw the javelin as far as possible, so maximum force transfer to the javelin is needed. So to increase the distance, long levers increase force transfer to the javelin. So the release of the javelin with a straight arm is important. So this is the law of leverage. To increase distance, increase the number of muscles involved in force production. And so this is the law of forces, and in particular the summation of forces. To increase distance, release the javelin from the highest point. This is projectile motion. And then to ensure no slipping in the run-up, footwear with good grip, but not too much, is important, and this is the principle of friction. For the fast bowling action in cricket, the intention is to deliver the ball as fast as possible towards a small target, so there is accuracy involved as well as force production. In order to bowl faster, release the ball from the highest point with the straight arm. This is the principle of leverage. To bowl faster, use a fast run-up. So these are the principles of speed and momentum. To deliver the ball without falling over, a wide base of support at ball release. It refers to the principle of equilibrium. So consider the sport that you are familiar with. What is the required outcome for a skill in the sport that you play? Consider which biomechanical principles apply to achieve this outcome. How may technique be changed according to one of the principles to achieve this outcome?